This is Zhi from Intel, and I have already worked in Intel for almost 4 years, and I'm working on graphics virtualization, aka Intel GVT-g. And now I'm one of the kernel maintainers of GVT-g device model in Linux kernel. And today I will go to show you that our progress from the production to upstream and also other design opens. And okay, yeah, let's see. First, let's going to take a look at our current status. Okay, as you can see that our official website is still on 01.org, and now we have a new developed mailing list on free desktop, and welcome to share your ideas and also patches. And the code repos now have been moved to GitHub and GVT Linux repo, and the whole development process is just like the upstream 915 code development model. And also for QMU, we still maintain some patches on topic branch for them because we haven't upstream our then support to to the QMU upstream code. And currently we still have the quarterly stable release mode model. It's like that we are going to pull one stable branch from the upstream branch, and we will test and fix the bugs, and we are going to release it as a stable release model. Yeah, but all the fix or the fix here will go back to the upstream. And we have been worked with Citrix for quite a long time, maybe from Zen client, and now we are working on Zen server. And this year we also worked with Red Hat, and our feature has been integrated into Red Hat RHEL 7.4 as technical preview feature. And the most big process we made this year is we pushed the whole project into upstream Linux kernel 4.10. Yeah, so yeah, this is the major contribution from our developers. As you can see that we developed a media device framework with Red Hat and NVIDIA, because NVIDIA is also going to upstream their vGPU code to the Linux kernel. And also there is already a framework in the Linux kernel named virtual function IO, and mostly it's used in device parser in QMU. And the maintainers, he extend that part to support the media device support, also in QMU. And because our device model needs now will work as a submodule in the host driver, so we need some kind of host driver changes. We worked with the Intel 915 team to achieve that. And also because we are using GPU shadow page tables, we need some kind of mechanism to track the guest page table change. So one feature we developed named page tracking feature is developed by Intel, also upstream in KVM. And the rest part is our device model, which means it has all kinds of hardware vGPU device knowledge here, and it's about 15,000 LOCs, and it was pushed by our team. So mostly this is a contribution last year from maybe all kinds of subsystem maintainers, yeah, and also all kinds of developers. Yep. Okay. So now you can see, because of the code upstream, we have to change our architecture to meet the requirement from the Linux kernel maintainers. Mostly, you can see that in the old model, previously in the old model, yeah, mostly the life cycle will managed by the QMU and libxl together, and mostly the libxl will pass the parameters, and there is some kind of trivial code in QMU which will talk with the vGPU lifecycle management in the device model to create vGPU, and also they can get the domain ID at the device model so that vGPU will be connected with a domain, right? So after that, then MTP model could assign vGPU resources, mostly like, that up maybe, how to say that, I will request a server or something like that, or write protect mechanism, yeah, with the domain ID and also to vGPU-S. But you can see that in the new model, all the vGPU lifecycle management has been moved to MDV framework there. And the libvirt will be responsible for creating the vGPUs, and it will get a UUID in the sysfs, and then it will pass that node to QMU, so that QMU will know that which kind of MDV it should be emulated to the guest OS there. And after QMU gets the UUID, it will know the immediate device information, like how much bar it has, how much maybe other kind of resource it have, so that it can map it like different VFL regions into QMU, and also it has a framework inside to emulate the a similar device in the guest OS there. So mostly it will also talk with KVM, because in QMU there are several KVM listeners. So KVM will set up some kind of resource, like, for MMO bars, it will trap or pass through, something like that. Yeah. And yeah, that's the KVM device MPT framework. Mostly it will talk with KVM. So you can see that in the new framework, all the vGPU life management will be managed by the MDV framework. And for MMO emulation, it also forwarded by QMU. Yeah, because the MMO emulation will be forwarded to QMU, and then in QMU will forward that MMO emulation to the device model. So mostly the device model only talks with the MDV framework, and yeah. And only in the MPT module, it will talk with the hypervisor only, yeah. So, okay. Yes, this is a briefly introduction about the new MDV framework in VFIO. So the basic usage model is that you can create and configure the MDV in the sysfs node, and then you got an UUID, and then you can attach the UUID into QMU, and then QMU will present the guest OS virtual device, so that the device driver in guest OS will attach to the virtual device. And also, just like what I said before, the IO trap will go to QMU first, and then QMU will deliver the IO trap to the device model, to the MDV driver here. So for MDV driver, it's just a part of the device, maybe an ordinary Linux driver. So it will attach with the ordinary Linux device driver, so that in that device drivers, in the sys node of the device driver, it will has an MDV support types folder. In that types, you can see how kind of MDV you can create. When you create one, then you can start to configure it, and then you pass that UUID to QMU, then you can use it. Yeah, so mostly it's a very generic framework for sharing one physical device between VMs. Like, you don't need to, for the MDV driver, you don't need to care about maybe how to talk with QMU, how to talk with hypervisor. Mostly it only talks with the framework, and it don't need to care about what kind of other things, yeah. And also, currently user in upstream kernel, GFX driver, we have Intel and NVIDIA, right? And there is also an S6, S390 IO driver used MDV framework already in the upstream kernel. Okay. Yeah, here is our then support upstream plan. Yeah, so the first stage is maybe we have to support both old and new model, just like what I showed to you. And the second stage is maybe we can use VFO MDV to manage the vGPU life cycle, but we cannot still use it, like what I showed you in the previous slides. Yeah. The stage 3 is, to fully enable VFO, and then we need to maybe refactor some code in QEMU. Like currently, the QEMU the VFO in QEMU code will only talk with KVM, right? We have to abstract that code and maybe extend to also talk with them. And because VFO was previously a framework for device pass-through, so then PCI device pass-through can also benefit from this generic framework. Yeah. So let's see something detailed. Yeah, this is the first stage. It means that we have to also upstream our previous vGPU lifecycle management into upstream kernel, and so that everything in the old mode could work. And also, in KVM, we will work in the new path, in the right side. We still work with VFLO and something like that. Yeah. So mostly we are going to use libxl and to manage the vGPU lifecycle, and also everything work like before. This is stage 2. Stage 2, I think, is also probably maybe easy to be upstreamed, I think, because maybe we only need to add a new attribute in VFO MDV so that we can get the domain ID from libxl, and then in the MPT device model, it can connect a vGPU with an domain. And so everything could work just like before. But you can see that we only use the MDV framework as a vGPU lifecycle management framework. So, and also, because we have some kind of DMA buffer sharing mechanism based on VFLO, so in the stage 2 or the service from VFLO, I think we can already use it at this stage. Yeah, just like what I said, I think it should be easy to move to this stage because it only needs maybe a few changes in the MPT driver, not the VFLO framework, and also we don't need to touch QEMU, right? Yeah. This is stage 3. As you can see that we have to refactor maybe code in QEMU. We have to let the VFO logic in QEMU to talk with them. And also, because the VFL is developed based on KVM before, so it has some kind of assumptions, like it will assume that all the guest memory comes from the user space memory or something like that. But in then, all the memory comes from the foreign page. So we might need to abstract that layer. Maybe memory comes from different place. We have to have different, handling logic at that place. And yeah, I think mostly we have to change the VFL code in QEMU and also VFL code in MDV. But because Zen already has its own PCI pass-through logic currently, so it might need to refactor or add some code to support the PCI pass-through through the VFLO function. Yeah. So another requirement I think is PV LMU driver, because we have a GPU shadow page table, and we have to access gas memory during our GPU command scan. So mostly if we have a PV MMU driver, and we don't need to introduce new P2M translation hypercall, and you might already seen a lot of discussion in the mailing list. And also we don't need to ping all the gas memory, because the PV MMU driver will do that. Then we don't need to worry about that. Yeah. Okay. This is the last page, call for action. Mostly welcome to, for ideas and also discussion in the mailing list about maybe MDV supporting then and PCI device pass-through supporting then based on VFLO. And currently we are also talking with the VFLO maintainers to see that, what kind of cooperation we could achieve, and how much plan he have already had. Yeah. Okay. Yeah. Thanks. So do you have some questions or? Yep. Does that work?
Try that? Nope. Yeah, there we go. Right.
Okay, yeah. Mm-hmm.
So, yeah, the VFIO for pass-through thing, I think the general direction is probably the opposite. I think the general desire is to move pass-through into Zen itself. Mm-hmm. So I'm not entirely sure VFIO is going to be the right way. Mm-hmm. You're probably going to be looking at some sort of broad equivalent hypercall interface into Zen to manage the life cycle of pass-through.
Yep.
I'm not sure. One assumes that ZenGT could fit into that reasonably well. Mm-hmm. It's already essentially a standalone emulator in the Linux kernel, so it would just have to basically talk to Zen to be managed. In a similar way. But, I don't think the VFIO direction is necessarily the right one for Zen. Obviously it is for KVM, mm-hmm. but that's because all the I/O is trapped through QEMU and KVM, and that's not the case in Zen.
Yeah. Yeah, but just like what I said, we can see how much maybe collaboration in the community we can achieve, right? We have to talk with a lot of guys.
Yeah, sure.
Yeah.
Hi. I have a question regarding new platform support. Do you plan, for example, what is your goal to involve in design, or maybe better support for new platform, for example, for Apollo Lake?
You mean for Apollo Lake?
Yes.
I'm sorry, it's a bit confidential here, but what I can say is, currently we haven't had a plan to maybe expose the Apollo Lake, support to Upstream, because we also have similar project development at this time. I'm not sure when the Apollo Lake support will be exposed. Yeah.
Any more questions?
Okay.
Okay.
Thanks.
Thank you.
Mm-hmm.